All right. Now we've talked about, all square roots so far. Now the next thing we want to talk about is higher roots, like cube roots, fourth power roots, fifth roots, so on and so forth. So let's go ahead and see what these would be like. Now, when we started talking about square roots, I told you that square root was the opposite or the inverse of squaring a number. So if you're talking about, cubing a number, its inverse would be the cube root. If you take a number to the fourth power or its higher power, then the inverse would be taking the fourth root or, a higher powered root of that number. So basically, in this case, we are going to look at cube roots, fourth roots, maybe a little bit of a higher value. So let's start with, nth root of a. Now, the n here will represent what root value you're talking about, okay? That's your index, and basically, if this was a cube root, the n would become a 3. If it was a fourth root, the n would become a 4. So we will call it the nth root because we don't know what n, represents. It changes with every problem. Okay, so basically the nth root of a number is a number whose nth power will equal a. So in this case, if this was, let's say, a cube root of some number, then you would have to see what number, cubed would have to give you the radical. And we'll go ahead and take a look at examples. So basically we're saying if you find the nth root of a and that is some value b, it basically means if I take b to the nth power, I should come back to the number a. Okay, just do the inverse and see if you come back with the value that you started out with. And again, this n will be the same as the other one there. Okay. Now, as I was telling you, n is what we call as the index or the order of your radical. Okay, so either one of those words, you may hear me using index or order of your radical. Okay. Now, what I would recommend you guys to do is, try and memorize, some of the perfect cubes, some of the perfect fourth powers, just so that when you're trying to find the radicals, your higher power roots, you are comfortable working with those numbers. So I'll give you a list of some basic powers here. Okay, so let's go ahead and see. If you take 2 to the third power, that will give you 8. Okay, so basically means if you took the cube root of 8, your root should be the number 2. In the fourth power, 2 to the fourth will be 16. Again, remember, when you're talking exponents, you're basically saying 2 times 2 times 2 for the third power. With the fourth power, you would multiply 2 into itself 4 times. Okay, you have 3 to the third power, which would be 27. 3 to the fourth power would be 81. 4 to the third power, 64. 4 to the fourth would be 256. 5 to the third, let's say, is 125. 5 to the fourth power would be 625, and so on. Go ahead and do it at least for 6, 7, 8, and 9. And if you want, you can try and keep this list handy whenever you are working on these sort of questions, so that by the time you get ready for your exam, you will have these memorized. So I would definitely go ahead and recommend you guys to start memorizing these basic powers here. So let's go ahead and look at some examples here. We'll just try and find some basic cube roots first. We'll start with something simple, cube root of 1. Okay, then we'll go ahead and find cube root of 27. Alright, cube root of 1. What do you think your cube root should be here when you're talking about the cube root of 1? It's really quite simple if you think about it. You are saying what number, multiplied into itself 3 times will give you 1, right? That's going to be the opposite of that. And the only way this is possible, if you take 1 and multiply it into itself 3 times, 1 times 1 is still 1. Okay, so in this case, the cube root of 1 is going to be the number 1 itself. Okay, and 1 is one of those unique numbers that this will be true for. Okay, what about cube root of 27? What do you think our root should be here? And this is where that table will come into play. Now if you look at this table here, you can see we said 3 to the third power gave you 27, which means that if you take cube root of 27, your root will be the number 3. Okay? So, I'm telling you, this table will be really useful. Go ahead and get started on that. Alright, what do you think about this example here? Cube root of negative 64. Now, I know with square roots we said you cannot have a negative inside the radical because that gives you a non-real number. Do you think that is true for a cube root also? Think about it. What number multiplied into itself 3 times can give us negative 64? And if you think about it, let's look at negative 4 to the third power. Go ahead and pull out your calculators or do it by hand, and you will notice that negative 4 to the third power will actually give you negative 64 as the answer. So with cube roots, you can have a negative number inside and you will still be able to find a rational answer. So in this case, your solution actually is going to be negative 4. Okay? And let's see, what do you think should be the cube root of 343? And in this case, you will see the negative is on the outside. So again, it basically means we're trying to find only, we're interested in a negative cube root here. So your answer will also have a negative sign. And what is the cube root of 343? So what do you guys come up with? If you solve that, you will realize that the answer here will be negative 7. Now, if you didn't have that negative sign in the front here, then you wouldn't have this negative out here as well, and then your answer would have been cube root of 343 is the number 7. Okay, now I want you to realize the difference between example number 3 and example 4 here. In example 3, your negative was inside the radical sign, okay, and that's why this answer turns out to be negative, because negative 4 to the third power gives us negative 64. On example 4, the negative was on the outside of the radicand, so you just carry over that negative. So that's why I was telling you, if you didn't have that negative sign, your answer would have been a positive 7. Okay? Now, cube root is one of those unique roots here, that you don't have. For one number, you will not have two different roots to it. The way cube root works is that if the number is positive, then your root is also going to be positive. And if the cube root, the radicand is negative, then your cube root is going to be negative. Okay? So it's quite different from a square root that we saw earlier. So the cube root of a positive number is always positive. And the cube root of a negative number, of course, will be negative. Okay, in other words, we can say there is only one real number, cube root, okay, for every real number. You're not going to come up with two different signs. The other thing you can try and keep in mind when you're working with higher roots, just like with square root, we said that you could not have a negative number inside the square root. This is true for all even numbered roots. So basically it means for square roots, fourth roots, sixth roots, eighth roots, 10th roots, whatever you talk about, if it's an even index, you will not have a negative number inside your radicand. With odd numbers, you can have negative numbers inside the radicand, but not with even number roots. And as you work with more examples, you will get used to, to remembering this property here. Because again, remember, when you end up with a negative radical, we basically said that that was going to be a non-real number. So if you want a real number root, then your radical cannot have a negative value inside of it. Okay? So let's look at some examples here that involve higher roots. We looked at cube roots. Now let's look at some examples that are fourth root or higher. Let's say fourth root of negative 625. What do you think the solution to that problem would be? Now again, we just talked about it. We said you cannot have a negative radicand inside an even index root. Now you can see you're talking about a fourth root. 4 is an even number, so that means you cannot have a negative inside your radical here, and in this case we would say this is not a real number. So we will not be able to find a solution, in the real number set. So that's all you can do for that fourth root of negative 625. What about the sixth root of 64? Again, what are we trying to say here? Some number to the sixth power should give us 64. So what should that number be? Because that is the same root that you will see here. And if you do a little calculation, you will notice that 2 to the sixth power gives you 64. So your root here is going to be the number 2. Okay? How about this example? Negative fourth root of 256. Now in this case, notice that the negative sign is on the outside. It is not inside the radical sign. So in this case, you can actually find an answer. So since the negative is on the outside, you will carry the negative over in your solution, and then just go ahead and find the fourth root of 256. Again, you can try and use that table that I was talking about earlier, and in this case you will see if you take 4 to the fourth power, you get 256. So that tells me fourth root of 256 is going to be the number 4 itself, and then of course we carry over our negative sign. Right, let's look at examples with fractions in them. How about if we're trying to find the cube root of 1000 over 27? So basically, what are we saying? You want to find the cube root of 1000 and you want to find the cube root of 27. So what number multiplied into itself 3 times will give you 1000? And if you solve that, you will notice that 10 to the third power is 1000, and 27 will of course be 3 to the third power will give you 27. Okay? And we'll look at one last example here with the higher roots. Now, we're talking about fifth root of negative 1 over 32. Since this is an odd numbered index, you can have a negative inside. Okay, so you can go ahead and find the answer to this problem here. And what do you think that should be? What number multiplied into itself 5 times will give you 1? Okay, just like we saw earlier, that number has to be 1. And since this is negative, we can safely say that the root itself is also going to be negative. And for 32, you'll do the same thing. What number to the fifth power will give you 32? And if you think about it, 2 to the fifth power gives you 32. So your root here is going to be negative 1/2. Okay, and you can try working with this. It may take you a little bit time to try and come up with what that root should be, but eventually you will find the answer. Okay, and in this case, of course, you can see we ended up with 2 as our value for the denominator here.